Section 6.2 is the trigonometry of right triangles. Okay, so here is our basic right triangle, right angle marked here, and then this angle is defined as theta. We have the hypotenuse of the triangle, and then the other two sides are marked in terms of theta. So this is the side that's opposite the angle theta, and then this is the side that is adjacent to the angle theta. Okay, and based on this angle theta, and this side being the hypotenuse, this side being the opposite, and this side being the adjacent, the trigonometric ratios are defined as follows. The sine of this angle, the sine of theta, is equal to the ratio of the opposite side over the hypotenuse. The cosine of theta is equal to the ratio of the adjacent side over the hypotenuse. The tangent of theta is equal to the ratio of the opposite side to the adjacent side. And then, just as in the last section, the cosecant is the inverse of the sine, therefore it's the hypotenuse over the opposite side. The secant is the ratio of the hypotenuse to the adjacent, and the cotangent of theta is the adjacent over the hypotenuse. Okay, so same as last section, these are reciprocal functions. Okay, and the way we remember this is using SOHCAHTOA. Okay, so SOHCAHTOA, S-O-H, refers to as sine is the opposite over the hypotenuse. Sine opposite over hypotenuse. Cosine is the adjacent over the hypotenuse. C equals A over H. And then the tangent is the opposite over the adjacent. So T-O-A. Okay, so SOHCAHTOA just helps us to remember sine, cosine, and tangent. You need to remember that cosecant is the inverse of sine, secant's the inverse of cosine, and cotangent's the inverse or the reciprocal of tangent. So if you can just remember this term, it will help you to remember all of the trig ratios. Okay, so I want to look at a triangle, and we want to find all 6 trig ratios given 2 or 3 sides of a right triangle. Okay, so in this picture here, I've given you 2 of the sides of the right triangle. Sometimes you're given 3, sometimes you're given 2. The only difference is the Pythagorean theorem is needed to find the third side. Okay, so in this case, I gave you the hypotenuse is 3. The adjacent side is 2. So the first thing you would want to do is find this third side. Okay, and 9, and we subtract 4 from both sides. So a squared equals 5. So that means this side is going to be the square root of 5. Okay, so first step is to find this third side, and then all we're doing is writing down the 6 ratios in terms of this angle right here, theta. So cosine, I guess I should have started with sine, but we'll start with cosine. Cosine is adjacent over hypotenuse. The adjacent side is the side that's next to theta. So 2 over 3. The sine of the angle is opposite over adjacent. The opposite side to theta is root 5 over the hypotenuse. And then the tangent of theta, tangent is opposite over adjacent. So opposite side over adjacent side. Okay, and then once we have these, it's pretty quick to write down the reciprocal functions. Secant's the reciprocal of cosine. Cosecant is the reciprocal of sine. And if I wanted to clean this up, multiply by root 5 over root 5. And then the cotangent's the reciprocal of tangent. So it would be 2 over root 5, which if we rationalize the denominator, we get 2 root 5 over 5.